Alright, in this lecture we're going to cover continuity. We're going to find out how to determine if a function is continuous. So when is a function continuous? Now you can think about it intuitively like this. If you can trace the function with a pencil without having to lift the pencil up, then it is continuous. This logic actually does not apply to all situations, and you cannot use this as an answer on your test. So let's go over a few mathematical terms that you need to actually memorize, and in order for a function to be continuous at a certain point, or for the function to be continuous in general, it must fulfill the following conditions. The first condition is that the function at that point, C, must exist. The second condition is that the limit at that point must exist. The third condition is that the limit at that point and the actual value of the function at that point must equal each other. So this is example 1. Is the function, and this is a piecewise function, which means that it's actually two different functions that apply before a certain value and after a certain value. So 2x plus 3 while x is less than 4, and then 3x minus 1 while x is greater than or equal to 4. So it's basically like two functions. Is this function continuous at 4? So does the function at 4 exist? Yes. In fact, you could just plug it in, right? You could plug in 4 into this right here. Condition 2 is that does the limit at that point exist? So on the right side, if you plug in numbers that are closer to 4 from here using this equation, then you'll get 11. Now, if you plug in numbers that are closer to 4 on the left side, like 3.9, 3.99, then you'll have to use this equation. And plugging those values in, you'll actually see that it approaches 11, right? So, yes, in fact, the limit at that point does exist. Condition 3 is, does the limit at that point equal the value of the function at that point? And we can see from condition 1 and condition 2, yes. The answer is yes. The limit at that point is equal to the value of the function at that point, which is 11. So it's continuous at that point. So there are three types of discontinuities. So there's the essential discontinuity. That's the technical term for it. Not that you have to memorize it or anything. But basically when you have something like x minus 2 on the denominator. In this graph, it's actually x minus 1 on the denominator. Basically, you're going to see a vertical asymptote, and the limit's not going to exist. So condition 2 will be dissatisfied in this scenario. This is a scenario where there's a jump. So usually you'll see it as a piecewise function. So the limit on the left side is 4, and the limit on the right side is 1, in the case of this graph right here. So it's not continuous at the point x equals 2 in this scenario. And it doesn't satisfy, actually condition 2 is dissatisfied. And then there's the point discontinuity. That's basically when a random point is pulled out and it's just pulled down or up. And this is kind of, it's pretty obvious when this happens. This leaves condition 3 dissatisfied because the limit at this point is 4, right? Because on the left side it's approaching 4, on the right side it's approaching 4, so it's 4, right? But in this graph, the value at that function is actually 2. So function 3 is left dissatisfied in this situation. And in summary, on the AP test, when questions involving continuity come up, it's best to just simply check if the three conditions are satisfied. So continuity is not that big of a concept in terms of how difficult it is to understand. It's pretty simple, but it's important that you understand it. It's really an essential part of what's going to come up.